Hi, today we're going to talk about the unit circle, which is an important topic if you plan on going in upper level math pre-calculus or calculus. We use the unit circle a lot. So let's go ahead and talk about it. So a unit triangle is a triangle whose hypotenuse is 1 unit in length. So to find the exact sine and cosine values for specific measures of theta, we must use special right triangles and right triangle trig. So first, let's remember our relationships. So remember we talked about the 30, 60, 90 triangle, where we have the lengths, angles of 30 and 60. So across from the 30 is x, across from the right angle is 2x, and x root 3. So if we want the unit triangle, which means a hypotenuse again of length 1, we would have to divide the hypotenuse by 2x. So if we divide the hypotenuse by 2x, then of course we would have to divide the other side length by 2x as well to keep the same triangle. So 2x divided by 2x would give us 1, so that would be then the hypotenuse. Notice then the x over 2x becomes 1/2, so that's across from the 30 degrees, which would be right here. And then across from the 60 degrees would be the x's again canceling out, so root 3 over 2. So 1/2 is 0.5, root 3 over 2 is about 0.8. So notice that the 1/2 is across from the smallest angle, and 60 is in the middle, and 1 is the largest number, which is across from the 90. So that's always going to be the case if that helps you remember which goes with which. So now let's go ahead and look at the 45, 45 degree 90 triangle. So remember for 45, 45, 90, the two legs of the triangle are equal and the hypotenuse is x root 2. So if I solve for the hypotenuse to become a length of 1 for a unit triangle, I would divide by x over root 2 on each side. So the hypotenuse across from the 90 degrees is 1. X divided by x becomes 1 over root 2. And then, of course, we want to rationalize our denominators. This becomes, when we multiply by root 2 over root 2, root 2 in the numerator, the square root of 2 times the square root of 2 is the square root of 4, which is just 2. So the square root of 2 over 2 for each of the side lengths. So these are our unit triangles, and it's very important that you know how to get this because this is how it relates to our unit circles. So we're going to put these on our unit circle. So it says, the diagram below shows a right triangle ABC placed on a unit circle. The unit circle, which is centered at the origin, means that we have a radius of length 1. So that means that the hypotenuse for these is using a length of 1, which means we're using our unit triangles. So we're going to label the triangles with the measures that we just found. So remember we said across from the 30 degrees, this side length is 1/2. That means up here is 60 degrees. So across from that would be root 3 over 2. For 45, 45, 90, that means this is root 2 over 2, root 2 over 2. And then for the next one, across from the 60, we have root 3 over 2. Remember, that means this angle up here is 30 degrees. So this would be then the 1/2. So it says the hypotenuse of each right triangle represents the terminal ray of the central angle, which intersects the unit circle at that point P. Complete the table to record the sine and cosine values for each angle measure in the first quadrant and the coordinates of the point where the terminal ray intersects the circle. And then let's think about our reasoning. So for the first one, we have 30 degrees. So remember in radians, we said that was pi over 6. And if you forget, remember you can always do 30 degrees times pi over 180. So again, those would cancel out to leave you with 3 pi over 18, which then reduces into pi over 6 if you don't have your calculator. So we want the cosine of the angle. Remember, for right triangle trig, the cosine is the adjacent over the hypotenuse. So in this case, if I'm looking at my 30-degree triangle, which is the first one that we have, cosine is the adjacent side. So the adjacent to 30 degrees would be the root 3 over 2, and the hypotenuse is 1. So that means that the cosine of 30 degrees would be equal to, in this case, root 3 over 2 divided by 1, so root 3 over 2. So then if I want the sine of 30 degrees, that is the opposite over hypotenuse. So now if I'm looking at the opposite side length is going to be the 1/2, and the hypotenuse is now 1. So that means this would be equal to 1/2 over 1, which is just 1/2. So now let's think about writing the coordinates that we have here. Remember to write the coordinates of a point on our xy plane. We go over x, which in this case x is root 3 over 2, and then we go up the distance of y to plot our point. So the y distance from here to here is 1/2. So notice that the point that we're plotting is root 3 over 2, 1/2 for point P. So this would be root 3 over 2, comma, 1/2. So let's keep going. So let's look at 45-degree triangle. So that's the middle circle. So for this triangle, 45 degrees, the radian measures is pi over 4. And so remember, a way to think about that is if 90 degrees is pi over 2, half of that is pi over 4. So then we want to find the cosine of 45 degrees, or pi over 4. So looking at our triangle here, cosine again, adjacent over hypotenuse. The adjacent is root 2 over 2, the hypotenuse is 1, so that means this is just equal to root 2 over 2. So then the sine of 45 degrees would be equal to the opposite over hypotenuse. Now the opposite is root 2 over 2, hypotenuse is 1, so root 2 over 2. And then to plot the points, we go over x and up y. So if we're going over x, we're going over root 2 over 2, and then we're going up root 2 over 2 for the point P right here. So this is just root 2 over 2, comma, root 2 over 2. And then the last triangle is using the reference angle of 60 degrees. So 60 degrees, if you count 1 pi over 6 and then have another pi over 6, that'd be 2 pi over 6, which reduces into pi over 3. So this is pi over 3. So if we want the cosine of 60 degrees, or pi over 3, that's the adjacent over the hypotenuse. So in this case, the adjacent is 1/2, the hypotenuse is 1, so that means that this is equal to 1/2. Then if we want the sine of 60 degrees, the sine of 60 degrees would be equal to the opposite over hypotenuse. So in this case, the opposite is root 3 over 2, hypotenuse is 1, so that means this is equal to root 3 over 2. And so then the points here, we're going over x, so over 1/2 distance, and up root 3 over 2. So that means the coordinates of point P would be 1/2, comma, root 3 over 2. So let's kind of think about some things here of what we just did, looking at our cosine, sine, and the coordinates of the point. So let's just look at it in general with this circle here. It says, given point x, y in the unit circle corresponding to an angle of theta in standard position, the sine of the angle, you'll notice, was equal to the y coordinate on our circle, which makes sense because if we label this x and we label this y, then sine is the opposite over hypotenuse, so y over 1 is just y. So it's the y coordinate of your unit circle. So then the cosine is adjacent over hypotenuse, so x over 1 would just be the x coordinate. So another way to write this point is we could say that the point is equal to the cosine of the angle, comma, the sine of the angle. So that's another way to represent the point. If you know what the angle measurement is, you would say the cosine of the angle is x and the cosine of the angle is y, which is very handy for our unit circle. So this is what we're going to want to know. And a way to remember that is to draw a triangle if you forget. And another way, thinking about this, cosine C comes before S in the alphabet. So cosine comes before sine, if that helps you as well. So let's think about the tangent. Remember, the tangent is the opposite over the adjacent. So the opposite is y, the adjacent is x. So tangent would be y over x, which is equal to then the sine of the angle over the cosine of the angle, because that's going to be something else that we're going to be taking a look at. We're not going to do too much with it today, but it's good to know to look at that relationship. And again, that's all using right triangle trig. All right, so let's think about beyond the first quadrant. So to infinity and beyond. The diagram shows a 45-degree central angle positioned in the second quadrant on the unit circle. So the first quadrant would have been over here. So we're just using that reference angle of 45 degrees and flipping it over into the second quadrant. So if we think about our unit circle, then if we think about this being in quadrants, then if we have a radius of length 1, then this point on our circle would be 1, 0. At 90 degrees, we'd have 0, 1. Here would be negative 1, 0. And this would be 0, negative 1. So if we flip our triangle to quadrant 2, it says state the measure of theta in degrees and radians first of all. So if we want to figure out what that measure is from the x-axis all the way to here, so we're looking for that standard angle. Well, if the reference angle is 45 degrees, we can just take 180 degrees, because remember that's right here, or if it's in radians, it would be pi. So we can take 180 degrees, so theta equals 180 degrees minus that reference angle, which gives us 135 degrees. So that means that that angle theta is 135 degrees. And then we want to figure out in radians what this is. So you could do in radians by converting it, or if you know your unit circle values, you would know that's 3 pi over 4, but let's say we don't know 135. If degrees, if we multiply this by pi over 180, then this would give us, when we reduce, 3 pi over 4. So that's a radian measure. So it says identify the coordinates of the point at which the terminal side ray intercepts the circle. So if we're looking at on our graph here, you have to remember that in quadrants 2, x is negative, right? So we have negative x and a positive y. So let's think about our 45, 45, 90 triangle. So 45, 45, 90, remember this is a unit of length of 1, root 2 over 2, and this was root 2 over 2. So now over here, that means if we're in the next quadrant, this would then be a negative x value, so negative root 2 over 2, and positive root 2 over 2. So that means that the coordinates now for quadrant 2 would be negative root 2 over 2, positive root 2 over 2. So it looks like the first quadrant. That means that if we think about our unit circle, if you know the first quadrant, then you know all the rest of the quadrants, because all you're doing is taking that reference angle for the triangle and that flipping it over across the y-axis or across the x-axis to get the value. So you're just changing the signs of the points that you have in that first quadrant. So that first quadrant that we talked about were these points up here. So let's go ahead and take a look at them. So we said then on the unit circles below, it says sketch the other 3 angles with the reference angles of 30 degrees, 45 degrees, and 60 degrees. So here we had 30 degrees. So remember, for 30 degrees, again, if you forget, we can come back here and look. We use this first circle, and so for 30 degrees, we said that point was root 3 over 2, 1/2. You could always draw the triangle if you forget. So that means this would be equal to root 3 over 2, comma 1/2. Well, so if we draw that triangle here and flip it over, then the angle that we're using is no longer 30 degrees, but 150 degrees from the x-axis to that point. But we're using that reference angle of 30 degrees. Same thing at 210, and same thing at 330. Well, those are all using a reference angle of 30 degrees. So the only thing that's changing is our points, either they're going to be positive or negative. So remember, in quadrant 1, all your points are positive. In quadrant 2, x is negative, y is positive. In quadrant 3, negative x and negative y. And in quadrant 4, maybe be helpful right here. So this would be negative, negative. And in quadrant 4, this would be positive and a negative y. This one was positive, positive. So then that means for 150 degrees, if we're going to write that angle, the only thing that's changing from the first quadrant is that becomes negative root 3 over 2 comma 1/2. And in the next quadrant, your x and y are both negative. So negative root 3 over 2, negative 1/2. And then in the fourth quadrant, it would be positive root 3 over 2, because now x is positive and your y is still negative. So we can do that for all our triangles. So if we have 45 degrees, then we're now using this triangle here. And if we flip that across the x-axis, and again flip it, these are all using a reference triangle 45 degrees. So remember, for 45 degrees, we said that this triangle was using root 2 over 2 and root 2 over 2 for each of those. So then that means this is root 2 over 2 comma root 2 over 2 for that point. So then the next one would be negative root 2 over 2 and then root 2 over 2. Negative root 2 over 2, negative root 2 over 2, and positive root 2 over 2, negative root 2 over 2. Because those are all using the same reference angle, 45 degrees, for that 45, 45, 90 triangle. So all using the same unit triangle. So the last one is using 60 degrees as this angle. So then that would be these triangles here. So then that means 120, 240, and 330. So those are all going to use that same point, but just changing the coordinates to be either positive or negative. So if it's 60 degrees, remember, then that means that the x-coordinate now is 1/2 comma root 3 over 2. It just switches from our 30 degrees because we're using the same triangle, but flipping it so that the angle that's the reference angle is 60 degrees instead of 30 degrees. So then this would be negative 1/2 and root 3 over 2, negative 1/2, negative root 3 over 2, and negative, or excuse me, 1/2, negative root 3 over 2. So those are the angles from our unit circle that we need to know, because then we can figure out what the sine and cosine is by using these points on our triangle. So go ahead and take a moment to pause the video and write the coordinates on here. So remember, we said there are 4 quadrants on the coordinate plane. So quadrant 1 uses x and y as positive. Quadrant 2, x is negative, y is positive. Quadrant 3, negative, negative. And quadrant 4 is going to be positive x and negative y. So again, pause the video, write the coordinates on. So let's start out with 0. So this, remember, is a unit circle. So the radius is 1. So we're going over 1, up 0. So then at 90 degrees, or pi over 2, we're going over 0, up 1. At 180 degrees, or pi, negative 1, 0. And that's 270. This would be 0, negative 1. So those give our what we call quadrant angles. So then if we start with the next one at 30 degrees, and if you forget, you could always draw your 30-degree triangles. Remember, cross from 30 is always the 1/2. So that means this x-coordinate to get to here is going to be root 3 over 2, and the y-coordinate is 1/2. And so all of those pi's over 6 are using 30 degrees as our reference angle. So that means all of those are going to use the same coordinate, but again, just change the sign. So as we showed before, negative root 3 over 2, 1/2, negative root 3 over 2, negative 1/2, and over here we would have root 3 over 2 and negative 1/2. So again, those all use that reference triangle of 30 degrees. So I highlighted it to make it a little bit easier to see. So then all the ones over 4 using 45 degrees. So remember we said that for the triangle, and again, if you forget, draw a triangle. So 45 degrees, this is root 2 over 2, root 2 over 2, and 1. So that means this is root 2 over 2, root 2 over 2. That means this would be negative root 2 over 2, positive root 2 over 2, negative root 2 over 2, negative root 2 over 2. And down here would be positive and then negative. And those are all using the 45 triangle. So that's going to flip over here. Only difference is we're just changing the quadrants. So then for the next one, we have 60 degrees. So now we're using the reference angle of 60 degrees. Remember, across from 60 is the root 3 over 2, across from the 30 is the 1/2, and this is 1. So that means this would be 1/2 root 3 over 2. And notice again, it's the opposite of what we had at 30 degrees. So then this would be negative 1/2 root 3 over 2, negative 1/2 negative root 3 over 2, 1/2 and negative root 3 over 2 because it's positive negative. And so then again, if you draw your reference triangles, these triangles are all using that reference angle of 60 degrees. So those are all corresponding together. And this is something that we need to be able to recall fast. So if you forget it, make a triangle. But to help us with things that we're going to be doing later, it's better if you try to recall them quickly. And we'll talk about more tricks to do that. But really, if you know the first quadrant points, and you know all the other quadrants, because again, they're just flipping and changing the signs across the axes. So we'll come back to this. So quadrant angles. A quadrant angle is an angle whose terminal side lies along one of the coordinate axes. Evaluate the 3 trig functions at the 4 quadrant angles. So remember, we said if we're on our unit circle, then we have the points 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So we have to remember that we talked about the coordinate points. So remember, we said up here that cosine of the angle is the x-coordinate, the sine of the angle is the y-coordinate. So oops, we're using that to think about as we're doing these problems. So I'm going to come back down here and write that again. So remember that it's always the points x comma y corresponds to the cosine of the angle comma the sine of the angle. So that means that with the sine, remember, is going to be the y-coordinate. Cosine's the x-coordinate. Remember, tangent opposite over adjacent. So again, if you forget, just draw that triangle. This is x and y and 1. So tangent of the angle would be y over x. So that means then the sine of 0 degrees, because we're using this up here for the table. So the sine of 0 degrees, we have to look at 0 degrees. So this is 0 degrees here. This would be 90 degrees, 180 degrees, 270 degrees, and back to 0 would be 360. So the sine would be the y-coordinate. So the sine of 0 degrees is 0. The sine of 90 degrees, or pi over 2, would be equal to 1. The sine of 180 degrees, or pi, would be 0. The sine of 270, or the sine of 3 pi over 2, would be equal to negative 1. That's how we get those values. So let's go ahead and do the cosine. I'll do it in a different color. So cosine is the x-coordinate. So cosine of 0 degrees or radians is 1. The cosine of 90 degrees or pi over 2 is 0. The cosine of 180 degrees or pi is negative 1. and the cosine of 270 is 0. So now for tangent, we're doing y over x. So for tangent, y over x, so tangent of 0 would be, again, if we look here, this is our x and this is our y, so 0 over 1. 0 in the numerator is okay, so this is just equal to 0. At 90 degrees, our x and our y points are here, so we have 1 over 0, which is not allowed. We cannot divide by 0. This is undefined. I'm just going to put u and d. So u and d equals undefined because we cannot divide by 0. So then again, here's my x and my y. So this would be 0 over 1, which is just 0. And again, x and y. So this would be negative 1 over 0, which is undefined. So that's how you would get your tangent on your circle. So let's go ahead and keep going. The next one say, use the unit circle to evaluate each measure. So we're going to be thinking about our unit circle values in order to help us so you can have your unit circle in front of you as we go through this. All right, so I've copied and pasted a unit circle here for us to see. So again, it's good to remember that it's always cosine theta comma sine theta for each of the points on our unit circle. So if I want the sine of pi over 6, I need to figure out where's pi over 6. It's right here on my circle. The sine is the y coordinate, so the y coordinate is 1/2. The cosine of pi over 6 would be the x coordinate. So since it's the x coordinate, the x coordinate is then root 3 over 2. And then again, that comes from our right triangles. We're just not drawing the triangle, but you can always draw the triangle if you need to. The sine of pi over 4. So here's pi over 4. The sine is the y coordinate. So the y coordinate would be root 2 over 2. And then the cosine would be the x coordinate, root 2 over 2 for cosine of pi over 4. Erase that. So what happens if it's not a value on our unit circle, but it's coterminal with a value on our unit circle? So if you need to find coterminal angles, then you have to either add or subtract 360 or 2 pi if you're in radians to find the coterminal angle and then find the sine or cosine. So we have the sine here, which means we want the y coordinate, so I'm just going to put a y there. So this is negative 30 degrees. If you don't know where negative 30 is, then add 360 degrees to find the coterminal angle. So this gives us 330. So that means the sine of negative 30 degrees is going to be the same answer as the sine of 330 degrees. So on our circle, find 330 degrees. The sine is the y coordinate. So that means that the sine of 330 degrees or negative 30 degrees is equal to a trig ratio of negative 1/2. Remember, these are trig ratios that we're finding because it's from a triangle. These are the side lengths. So then the next one, we have the cosine, which is the x coordinate on our circle, 570 degrees. So subtract 360 to figure out what it's coterminal with, which gives us 210. So the cosine of 570 degrees is coterminal with the cosine of 210 degrees, which means we're going to get the same trig ratio. Where's 210 degrees? Right here. Cosine's the x coordinate, so negative root 3 over 2. So then we want the sine of 510 degrees. So where's 510? It's not in our circle. So we need to subtract 360 degrees to figure out where it's at. So if I subtract 360 degrees, this is equal to the sine of 150 degrees. So on my circle, 150, sine is the y coordinate. So the y coordinate is equal to 1/2. All right, let's keep going. Cosine of negative 480. So now we have to add 360 degrees to find the positive angle measurement. That gives us negative 120 degrees, which means we need to add another 360 degrees to get that because it's still negative, which gives us 240 degrees. So the cosine of negative 480 is coterminal with negative 120, which is also coterminal with the cosine of 240 degrees. So on my circle, 240 is here. Cosine is the x coordinate. So the x coordinate is equal to negative 1/2. So that's when we're in degrees, but now we have a radian measure. So if I have a radian measure, then 10 pi over 3 is not in my circle, but I do notice that I have values that are over 3, right? Pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. So it means this is coterminal with a value on my unit circle, I need to find it. So 10 pi over 3, we subtract 2 pi because it's over 2 pi in this case. I need a common denominator, and you need to be able to do this without your calculator. So multiply this by 3 over 3 to get a common denominator. So this gives us 10 pi over 3 minus 6 pi over 3, because 6 pi over 3 is really 2 pi. So 10 pi over 3 minus 6 pi over 3 gives us 4 pi over 3. And what do you know? 4 pi over 3 is the same as 240 degrees. So the sine of 10 pi over 3 equals the sine of 4 pi over 3, which would be the same thing as 240 degrees, and the sine is the y-coordinate. So that means this is equal to negative root 3 over 2. And then the last one that we have is going to be the cosine of negative 8 pi over 3. So if I have negative 8 pi over 3, and we're going to add 2 pi because this is negative and there's no negative 8 pi over 3 on here. So then multiply this by 3 over 3 to get, again, the common denominator. So negative 8 pi over 3 plus 6 pi over 3 gives us negative 2 pi over 3. Well, I see a positive 2 pi over 3, but I don't have a negative 2 pi over 3. So that means I'm going to add another 6 pi over 3 because, again, that's adding 2 pi. We just already got the common denominator when we did that here. So that gives us 4 pi over 3. So it's actually using the same angle that we just did, but the cosine is the x-coordinate. So that means this is equal to negative 1/2. So that is how we use our unit circle and how we get the values. And then again, we'll talk about some more tricks and tips tomorrow. But that is all for our unit circle.